Hey guys, today it's all about the LARUS Vario system. We will first chat with the developers at the Aero in Friedrichshafen. Then I will show you how to install it, the common mistakes with the installation, how to set it up so that it works perfectly in the air. And I will also show you how to make an update for the Vario display and also for the sensor unit. And then at the end, we will have a great flight in the French Alps. So let's get started.
Hello, we want to shortly talk about new developments in instrumentation, especially for gliders. And the trick today is that we have very precise sensors available that can be used to improve the complete instrumentation for gliders. Glider pilots are especially interested in learning about the energy that they gain or lose, and the instrument for this is the variometer. Variometers used to be built with measurements only of pressure. Unfortunately, the pressure signals are pretty noisy because of the properties of the surrounding air, and now we have other sensor systems available that can be used to very much improve the quality of the signals. And the trick is basically GNSS, satellite navigation, and INS, which means observing the motion based on acceleration and gyro measurements. Incomplete, this means that you would not monitor the changes of pressure surrounding the plane, but you just monitor the motion of the plane and use algorithms to provide the variometer signal based on those signals. One trick is important. The algorithms need to calculate everything not in the coordinate system of the world provided by the satellite receiver, but in the coordinate system of the moving air. And this means you also need to know about the wind surrounding the airplane very precisely. And this, fortunately, can be done using sensor fusion algorithms that use pressure measurements, satellite-based information, GNSS information, and INS information, which is basically the movement of the sensor mounted to the airplane. Finally, you get a variometer information that has absolutely no delay. So if you would make a movement like this, your variometer needle would go like this. There is absolutely no delay. And this helps pilots to find thermals and to avoid downwash in a very short time scale. This helps glider pilots to perform better flights.
So we were very happy that Stefan invited us as the LARUS development team. End of 2020 we started developing a variometer, which is now available here as the sensor unit. And as this is on the market for about 2 years, we had some more time in the background to concentrate on developing a front-end system which can be installed in a glider in a standard 57mm cutout. Actually, we started working on this display end of 22, I guess. We had a prototype flying almost 1 year now, and at the beginning of this year, 2024, we finalized this version with a very big 57mm display which really fills out the instrument panel. And we gathered a new colleague who is working on the software of this display, and he's implemented this software completely in Rust. We are really concentrating on displaying wind information so that we as a pilot learn about what does the wind show and tell us. And this is a very new field of gliding, very new experience. So I'm flying with the LARUS system for 3 years now, and yeah, it's a completely different experience. So when you're sitting in a glider flying with such a new variometer system with such a low time lag, and you're comparing the feeling when the terminal is lifting you and you're looking on the screen of the display, you realize that the feeling and the displayed information just fits together. and is a perfect match. So trying this out is a very new experience, and you see how much better these new INS and GNSS space variometer systems are.
The LARUS system consists of two units. You have the sensor unit and then you need display. We now have a 57mm standard cutout Vario display which has a really huge active display area. But you can also just use the SteFly nav or the old Open Vario as a display and get also the Vario audio out of the SteFly nav or the Open Vario. So in this case we have installed both the Vario display and also the SteFly nav. And in general you need to know there are two versions available of the LARUS sensor unit. We have the essential version which has a single GNSS and it also has a magnetic heading sensor. You all know magnetic heading sensors were used previously before also for the butterfly Vario, for example. If you get a good installation, it's a great tool, it's really working great, but you definitely need to take care with other magnetic stuff around in the instrument panel and so on. So there are gliders where it's not so easy to get a good solution. Therefore, and of course it's also more precise, we have the dual GNSS version where we don't need the magnetic heading. We have two high precision GNSS antennas, one in the rear and one in the front. For gliders with a carbon fiber fuselage, for example, you can mount it here at the end of the canopy and here somewhere in the front of the canopy. It should at least be 1 meter far away. And with this already you get a better and more precise heading than with a magnetic heading sensor. Of course it is better to install it, let's say 2–2.5 meters far away. Like in the ACE 33 for example, I have the front GNSS antenna installed here below the instrument panel cover and the rear one at the end of the engine compartment. Okay, let's open here the canopy and I will start to show you a little bit more. We will put off the canopy here. That's the heart of the LARUS, that's the LARUS sensor box. What is important here? The essential version needs to have a good magnetic heading, so you need to be careful where to position it, where to place it. We tried to get it as high as possible so that we are as far away to the avionics and the cables and so on. And that's why we built here this mount with these carbon fiber rods, and it is fixed. That's also very important. There is an acceleration sensor in there, so if it's vibrating all the time, of course that's not good for the result at the end. The magnetic sensor is more located here in the front side, more to the pressure hoses, and you can install the sensor like you want, you can rotate it and so on, but then later on of course you need to adjust and configure it in the software. What are the common mistakes with the LARUS installation and what we have experienced from some customers in the last year? So first of all, the essential version it is really important to position it far away from magnetic stuff. So here in this case the power flam fusion is here in the front, that's not a big deal, and we just try to have, let's say it's 10, 15 to 20 centimeters far away from most of the avionics, and there are not really proper magnetic materials close to the sensor unit. And especially at the side of the pressure hoses, here is the magnetic sensor, so from this point on it is important to be far away. One common thing is that these GPS antennas have a small magnet in there, so you need to be really careful that you don't have a magnet in there. That's one mistake. Then what is really bad also for the magnetic field are loudspeakers, because they work with a magnetic changing field to make the noise. And then we also had some problems with, let's say, USB charging ports, for example, cheap ones for cars and so on. And these power converters, they can make a lot of noise, and also they can induce some magnetic field also on the cables. In general, it would also be the best to twist cables if they are close to the magnetic sensor. If you twist the plus and the minus, then it is better, because then there should not be a magnetic field anymore. And of course, loops of wires are not good. Also, one common mistake is to place the LARUS sensor unit really close to a compass. These mechanical compass, they also have a magnetic field. And then the second bigger problem is also that we had customers who just installed the GNSS antenna somewhere, say perhaps even here below, or they have some cables above it and it's super close to other GPS antennas and so on. There you definitely need to know the antenna has a 180-degree dome around, so half a bowl around the antenna. So if we make a turn, for example, we already have 45 to 50-degree angle, so that's already cut off slightly, this area where we have good satellite connection. That's why it's super important to not have any metal or carbon fiber parts on the side or above of the GNSS antenna. Then the second improvement is to use a ground plate with at least 10 centimeters in diameter. That also makes the GNSS reception better and also covers other noise from below and so on. So that's something which is also highly recommended, to use a ground plate for the GNSS antenna. And it doesn't matter if it's the single GNSS or the dual GNSS version. On both of these GNSS antennas, it's necessary to take really care. Because this system only works with very good sensor input. Just quickly, for the installation of the GNSS antenna, for the single GNSS version, it is completely fine to install it, let's say, here in the front of the instrument panel. Just take care, you also have usually the canopy flasher installed somewhere above here, so don't put it directly below the canopy flasher. And then for the dual GNSS version, you need to install 2 GNSS antennas. Usually the common thing is to install one here in the front, below the instrument panel cover, or above the instrument panel cover. That doesn't matter too much. And then for the second antenna, you should at least place it at the end of the canopy. That's a simple version which works for most of the gliders. Of course, it is nicer if the glider has a glass fiber fuselage. Then you can just install it below here at the end of the luggage compartment, for example. With gliders with carbon fiber fuselage and a sustainer or a self-launch engine and so on, there are perhaps possibilities to exchange the motor doors with glass fiber doors, especially for dual discus turbo or discus 2CT and so on. We already tried this to rebuild it out of glass fiber and integrate their GNSS antenna. And for a brand new glider like the AS33ME, Alexander Schleicher offers an option to make the last part of the engine door in glass fiber, where you can then also just position the rear GNSS antenna. We would also have the option for an outside GNSS antenna. It is quite a small 3D printed, aerodynamically good design, and it's also a simple solution. You just drill a 3mm hole and stick it on with a 3M VHB tape, and you are good to go, and you have the best possible GNSS reception, and so your Vario system will work perfectly. I'll give you a super quick overview of the Vario display. For more details, have a look into the manual of the Vario display. So what's super cool about the Vario display is we have the biggest possible active display area. So it's a complete circular display. It is super bright. We have the biggest area for information, which is really cool. First of all, you have only here these 2 rotary encoders. The lower one here is for the MacCready. You can adjust it. And then the other one here is for the volume. For the acoustic Vario, you can either connect to the Vario display a loudspeaker, which is recommended, or you can, if you have installed a SteFly nav and have it connected to the LARUS, then you can also just use the sound of the SteFly nav, and XCSOR or OpenSOR is also generating a Vario sound. No speed to fly sound up to now, only the Vario sound. The Vario display also generates speed to fly sound. Then there are different possibilities to connect a speed to fly switch. For example, you can connect here the switch of the remote stick directly with wires to the LARUS Vario display, or you can use the USB input here, which was used for the Open Vario, and let it send via the SteFly nav to the Vario display. Or you can use an automatic switch between the speed to fly. So it's up to you. And then we have two different types of menus. The first one, which you use for the normal flight, you can adjust your water ballast, your bugs, your pilot weight. And we can also switch here between the Vario and an horizon. The second menu is here with a long press. That's what we use now. First of all, you have the views here, so you can adjust what you want to see in the center. So here in the center, for example, now we have here a wind arrow, or it is a dual wind arrow, the live wind and the long time wind. We can even adjust the time constant and so on. We have some information up here and down here. That's what we can adjust. And these information can be adjusted for the circling mode and also for the straight flying mode. We're here, views, info, content 1, average climb rate, drift angle, wind delta, wind average wind. Then you can select here the center circling, so what you want, what assistant, or if you want to have the wind displayed, we have the option a dotted assistant, dotted thermal assistant, or the spider assistant. The spider assistant is about the same as in XCSOR, and the dotted assistant is more common, let's say, from LXNAV Varios and so on. And then you can set up what you want in the center straight. So here I use the double arrow, for example. Then that's a test. We implemented also the energy arrows. Especially this one is super cool to see when there is a big change between both wind arrows, and in a lower altitude it can directly display where you need to fly into the thermal. That's why we implemented this one. And yeah, display rotation, of course, that's for the initial setup, very important as well. So you can install the Vario display in all 4 directions. It's a circular display. Of course, this encoder module here will then rotate as well, and the size of the device in the background is not symmetrical, so you can try to rotate it so that it fits to your glider. And then we have here a glider symbol. I like to have it off, but perhaps in clubs it helps to know that in straight flight the wind is pointing to your glider and it's not north up, and while thermaling it's north up. Okay, so that's the views. It's, let's say, a basic menu, but you have already a lot of options. Of course, there are many more to come. Then we have some advanced settings. You can even create a user profile, and there's even an option to directly connect our canopy flasher to the system, so that it will automatically start and stop when you start the flight and when you're back on the ground. You can even install a gear warning here to this Vario display, train control, and so on. Then we have the polar settings. We need to adjust the glider. We are here in ASG29. Let's set it up for 18 meter. You have the empty mass. It's about okay, I think. The max ballast, yeah, I don't know, reference weight and so on. There are predefined polars available, but of course you can also adjust your own polar. Yeah. And then we come to the basic setup. That's the most important thing, to set up the LARUS sensor so it knows how it is installed and that it works perfectly in the air. This menu is super important. We implemented here a new feature so that you only need to lay down the left hand wing, then you press here, left hand wing is down, then you put the right wing down on the floor, also wing straight, and then it calculates the orientation automatically. So with these information, it knows how the sensor is installed. Of course, what is super important, you cannot do these settings here when the canopy is open in my case, because we have installed the sensor here on the instrument panel, so it is tilted up. So you will of course mess up the setup completely. So that's why it's important to close it. It's better to just sit in there, have a second person on the ground to do all the other things. And you can also do the level flight adjustment when you just fly in the air with the best glide ratio, for example, and then you can also level the horizon there. On the other hand, of course, you can lift it up, get it into the weighing position, and then it is also a good setup. That's it for the setup of the essential LARUS sensor. For the dual GNSS version, you also need to let the system know how far away the GNSS antennas are installed, how much higher or lower one is. So there is one step further which is necessary. But then after this, that's it. You need to fly. For the magnetic heading sensor, you need to make some normal turns, left-hand, right-hand turns and so on, and the system will learn about the magnetic distortion in the glider. So it is a self-learning system, it will get better. So after the first winch launch, for example, the system won't work perfectly. You need to give it a little bit of time, let's say 1 hour of flight or 2 hours of flight, so that it gets better and that it can adjust the magnetic heading sensor. Now let's start with doing a software update. I just have here the micro SD card. I put the binary file on the micro SD card in the main folder or in no folder, just on the SD card. Now I plug it into the slot here, and then it is time to switch on the system, and then it automatically should make the update. For the Vario display, the update procedure is exactly the same. We just have an SD card, a micro SD card with a binary file on, and we plug the SD card in here at the rear side. Okay, and then we also turn it on. And now the firmware update is installing. We have the new latest firmware update. You see here 3.85, and we are still missing here the GPS because we didn't attach the canopy up to now. And we have here a quick connector so that in the case of an emergency bailout that the canopy can disconnect, because we connected here the GNSS antenna or have it installed on the canopy. I'm super happy to fly with the LARUS. I won all my world champion titles with the LARUS, and yeah, at the moment I would say there is no better system available. Also live wind works super quick, super precisely, especially with the dual GNSS version. It's just the best possible sensor out there on the market. So if you are interested, check it out on our webpage at SteFly.aero. And now I will show you some footage from the air and enjoy this nice landscape here.
Especially in mountainous terrain, the live wind display offers a significant advantage and a major safety improvement. It helps you understand what the wind is doing and why a slope is or isn't producing lift. But even in flatlands, changing wind patterns around thermals can indicate both the location and strength of rising air. To clearly show these rapid changes in airflow, we've added the option to display a third wind vector, also known as the energy arrow. One of my personal highlights is how quickly and accurately the system displays air movement during straight flight. By filtering out horizontal gusts, it prevents accidental loss of speed in turbulent air. And thanks to the ultra-fast response, I can instantly judge whether the line to the left or right is working better. In circling flight, the LARUS Variometer makes centering easier and more efficient, thanks to its precise and immediate vario feedback. Combined with a centering assistant, it becomes an even more powerful tool for staying in the core of the thermal. Here you can compare the variotones for yourself. This one is from x-alps running the SteFly nav device. And this one is from the Vario display. Which one do you prefer? Let me know in the comments.
If you enjoyed this video, make sure to give it a like, check out our webshop at stefly.aero, and then I will see you in the next one. Cheers!